They told us building a metro always means tearing a city apart. Streets closed for years, asphalt ripped open, traffic rerouted into chaos, entire districts frozen in construction dust. But today, that rule breaks. No open trenches, no jackhammers screaming through concrete, no barricades swallowing entire boulevards, just construction, happening silently beneath your feet. If you're fascinated by impossible machines and futuristic engineering like this, subscribe now, because this is where cities begin to change forever. From above, nothing looks different. Traffic lights switch from red to green. Cafes serve coffee. Buses stop and move again. But deep below the asphalt, something extraordinary begins to move. Engineers call it the streetless metro builder. A machine so advanced it doesn't simply dig tunnels. It manufactures an entire underground transport system as it advances, meter by meter, layer by layer. Traditional tunneling is loud. It shakes foundations. It cracks plaster. It triggers complaints before the project even begins. This machine was designed with one absolute rule: the surface must never notice. It starts from a hidden entry shaft, concealed inside a warehouse, an industrial yard, or a sealed logistics zone. From there, modular segments descend like the body of a deep-sea leviathan. Heavy steel rings, reinforced drive units, power modules, stabilization systems. Each section locks into the next with hydraulic precision. Then, the cutter head awakens. It does not tear through earth violently. It rotates with calculated pressure, guided by seismic scans that map every cable, every pipe, every foundation above. But the real innovation is not the drill itself. The secret lies directly behind it. As soil is displaced, a reinforcement ring deploys instantly, clamping the ground before it has a chance to shift. Micro-injection nozzles release expanding composite foam into unstable pockets. Loose sediment transforms into engineered structural stone within seconds. Sensors monitor pressure in real time. If the ground above moves by even a fraction of a millimeter, the system recalibrates. It bends instead of breaking. Traditional systems dig first and build later. This machine does everything at once. Behind the cutter, the tunnel lining forms immediately. Not crude concrete segments. A multi-layer structural shell. Load-bearing outer frame. Vibration-damping inner layer. Insulated cable channels built directly into the structure. The tunnel becomes a living shock absorber. Power conduits slide into protected spines along the walls. Data lines lock into sealed compartments. Ventilation ducts unfold like mechanical lungs. Drainage channels carve perfect slopes so water can never collect. Above ground, life continues untouched. Below, a fully finished railway corridor advances through darkness. The machine approaches older neighborhoods next, where foundations were never designed to handle movement. Pressure drops. Speed slows. Stabilizers widen. The load spreads outward like snowshoes across fragile ice. Every vibration is analyzed. Every oscillation corrected before it becomes visible. Then comes the greatest challenge: building a station without opening the street above. Instead of carving a massive cavern, the machine expands space gradually. A small chamber forms. Reinforcement ribs deploy instantly. Another chamber expands beside it. Then another. Piece by piece, an underground cathedral begins to grow. Support ribs interlock into a skeletal dome. Structural panels seal the frame into a rigid shell. The Earth does not collapse. It transforms. Escalator shafts drill upward but stop just beneath the street. Later, discrete connections link into basements, plazas, and transit hubs. Inside the forming station, the platform bed prints itself perfectly level, aligned to the millimeter. Safety barriers mount automatically. Embedded lighting calibrates for human comfort. Behind the station, Build Another Factory begins its work. Sleepers position themselves along the tunnel floor. Steel rails feed forward continuously. Laser alignment systems guarantee perfect geometry across kilometers of underground distance. Robotic welders fuse rail joints into seamless steel. Power systems mount along the walls. Signal networks activate silently. Before the first train ever runs, acoustic insulation is installed. The tunnel becomes a controlled sound chamber. Noise stays underground. The city above remains calm. Now the route approaches a river crossing. Water pressure here can crush tunnels like paper. So the machine shifts configuration. External clamps tighten. Structural lining thickens. A dual shell barrier forms with a protective buffer between water and the metro interior. The machine moves beneath the river silently. When it emerges, it accelerates again. Side tunnels branch outward like arteries. Junction chambers expand, ready for future lines. Maintenance drones begin patrols even before construction finishes. Scanning for stress microfractures, temperature shifts. If a defect appears, repair happens instantly. Resin injection, laser sealing, structural integrity restored. Above ground, people notice nothing. Until one morning, a new metro entrance appears. A polished stairwell, soft lighting glowing below, connected to a station that didn't exist yesterday. Inside, air flows quietly. Digital signage activates. Platform lights glow to life. Track power tests begin. Stable readings confirm the system. Then the final test. A pilot train moves forward into a tunnel built without digging streets. It glides smoothly, silently, because every millimeter was engineered in motion. Stations illuminate like underground constellations beneath a living city. When the machine completes its final segment, it retreats into the darkness. The Leviathan disappears. But the metro remains. What once required years of chaos now happens in silence. And once cities learn to build like this, the streets above will never be the limit again.